Good morning, students. So let us discuss the graphical representation of linear motion today. What is a linear motion? I have written several names of it: linear motion or rectilinear motion or motion in straight line or one-dimensional motion. They are all the same, right? That means when a body, say it started moving from here and it is moving in a straight line itself, this is called linear. It is motion in a line, no? So linear motion, or this is rectilinear motion, it is called. You have studied in class 7. And so moving in a straight line, so motion in straight line or one-dimensional motion. Okay, so these are the names for this. So we will be discussing three things: displacement time graph, velocity time graph, and acceleration time graph. Today we are dealing with displacement time graph, right? So what is a displacement time graph? Whenever we draw a graph, first learn what you need to do for making any graph. We have discussed a graph in simple pendulum also, right? So for making a graph, we need two axes. Okay, this horizontal one is called the x-axis and the vertical one is called the y-axis. For the displacement time graph, we will represent the x-axis as time. Okay, x-axis will be representing the time and y-axis will be representing the displacement. Okay, mostly that quantity is taken on x-axis, on which on changing will change this thing. Okay, means this y-axis thing will be depending on this. Okay, so whenever there is an emotion, as time changes, displacement will happen, right? It is not like when displacement happens then time will change. No, because suppose there is no displacement, will the time stop? No, time will keep on moving, right? So when as the time is changing, the displacement may change or may not. That is what we are going to study. Okay, so this thing we will be discussing later on, that slope of a displacement time graph gives velocity. This I have just written for you all, but we will be discussing it later on. So chalo, about the slope we'll see later on. So let us discuss the first case, when a body is stationary. I have already drawn the axis. When a body is stationary, okay. So first thing, let us say there is this point O. See this point where the axes are meeting, that is called O. That is the origin or zero. Okay, that shows the starting point in any graph. Okay, so this is known as origin, and this mostly represents the zero, right? So first understand, suppose a body is moving like this. Okay, the point from where it started is known as the origin, right? Or in order to study the motion, we will always take a reference point origin. Okay, so here the body is stationary. Now suppose the body is here. Okay, it is stationary over here, it is not moving. So its displacement from the origin, say this is 5 meter. Okay, but it is not moving now. The moment we started to study this, that moment, that is t is equal to 0, at that point its distance from the origin was 5 meter, and from that point only we are watching it as stationary. Okay, so time will keep on passing, but the body is not moving, right? The body is not moving. That means at time 0, the displacement was 5 meter. Suppose this is 5. Okay, 1 2 3 4 5, this will be marked something. Suppose this point gives us 5 meter. Okay, so and suppose here on time axis we have 1 second, 2, 3, 4, 5. Every time we are not going to mark these things. I am just telling you to just to make you understand this. Okay, so this will be marked like this. So at 1 second, when you started noting, observing the thing, so after 1 second also it will be having the same distance. At 2 second, what will be the displacement? Again 5 second. This vertical distance will show us the distance and horizontal distance will show us the time. At 3 second, again 5. So this is not changing. If we join these points, what is happening? We will get a horizontal line. Okay, that means at each and every instant, even in between fraction of seconds between these, at every point of time, the body was not moving and it was having a distance of or displacement of 5 meter from the origin. So this will always show you a horizontal line, right? So whenever a body is stationary, the displacement time graph will be a horizontal line, right? So wherever you see a horizontal line, all these things will not be marked. Suppose I say this is a displacement time graph. I say this is T. I denote it by S. Displacement is always denoted by S. Okay, and I draw it like this. Tell me tell me about the motion of the body. Just looking at this graph, because the line is horizontal, you will immediately say that the body is stationary, right? Okay, so this is done. Horizontal line means the body is stationary. Next is when the body is moving with uniform velocity. Okay, now the body has a velocity. Okay, it is moving. It may be moving slowly or fast, but it is moving. So whenever a body is moving, see, now the body is moving. Okay, this was origin. Suppose I have a car or something, started moving from here. It is moving, 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 moving. What is happening? Its displacement from the origin is increasing. It is going far and far and far and far, right? Now displacement is increasing as the time is changing. This is origin. This is showing me the time. This axis is showing me the displacement. And what is happening? As the time changes, as the time is increasing, displacement is increasing. How will I show it? At point 0, displacement was 0. At 1 second, there is some displacement. At 2 second, displacement increased like this. At 3 second, it again increased. So ultimately, this will be a straight line passing through the origin. Straight line like this. Can you see? So now, see, wherever we find this type of a graph, this graph shows that whatever quantity is on x-axis, when that is increasing, the y-axis thing is also increasing. That means this thing is proportional to this one. So what is happening here? As the time is changing, the displacement of the body from the origin is increasing. Are you able to understand it? Graph study is very important to learn, right? अब देखो इधर, see, when here I have, this was the 0 instant, time is increasing, time has increased to this much, abhi displacement has increased to this much, time increased to this much, displacement increased to this much, time this much, displacement this much. At a particular point, this is showing the time, this is showing the displacement. Now see, if I have any point on the graph, at this point, what is the time? The horizontal distance of this point. is the time, is showing the time at which instant we are noting the displacement, and vertical distance of this point will show us the displacement. This is how graph is read. Okay, now this case has two things. There can be two things. First we discussed, and the second thing can be, this is the origin and the body was already here. Suppose the body was already here. Origin means a reference point, right? Now the body is returning back to this point. If the body is returning back to this point, what is happening? The displacement is decreasing. The displacement is decreasing, isn't it? So initially the displacement was something very high. Say this was the displacement initially. What is happening? As the time is increasing, the displacement from the origin is decreasing. So what will happen? This type of a line we will get. Understood? Ultimately, when the body reaches, if the body reaches to origin, the displacement will become 0. So at that point of time, the graph will reach this point. What is happening here? Time is this much and displacement, vertical distance. Is there any vertical distance? No. That means the body has reached the point of origin. Understood? I hope it is clear. And you have to draw, say this is S and this is T. One more thing in this graph, I would like to take an example that is given in your book. So, or let me draw it here, a smaller one. See, this is S, this is T. Suppose I draw a graph like this. What does this graph show? Can you understand this? What is happening over here? What does this graph show? See, this line, itna, see, just see this much. Isn't it the same as this one? So what was it showing? As the time is increasing, the displacement is increasing. Displacement is increasing means that the vehicle, the body is going away from the origin, right? Now see this one. Isn't it similar to this? As the time is increasing, the vehicle is going towards the point of origin. So what is happening? The body started from the origin, moved up to a particular point where the displacement was maximum, and then came back to its original point. Understood? The body was not moving like this. No, the body simply went in a straight line and came back on the same line. Understood? But what happened during this process? The displacement increased to a maximum and then decreased to a minimum. So the displacement increased to a maximum. See here that the displacement is, vertical distance is increasing to a maximum, and then it is decreasing to a minimum. See, the vertical distance is decreasing. Okay, so this example is given in your book also. You can just read it once. Now there is a third case, that is if a body moves with varying speed. Okay, if a body moves with varying speed means during the path the velocity is increasing but in a varied manner. The displacement is increasing, okay, but the speed was changing every time. Okay, so see, the body is going from origin in a particular direction. Okay, it is going away from the origin. So what should be the nature? That the displacement is increasing, right? Displacement is still increasing, but here what is happening? The velocity is not uniform. The speed is changing but not uniformly, means the speed is not uniform, the speed is not constant. Here the speed was uniform, okay, the velocity was uniform, that means it was moving with a constant speed. Here it is moving with a varying speed, means speed is continuously changing. Suppose for a small instant the body was moving with 5 meter per second, then it started moving with 10 meter per second, and so on. Okay, but the displacement is still increasing, so here we get a curve like structure. Okay, you get a curve like structure. Okay, it is not a straight line, it will be a curve. Now talking about the slope. So slope of a body, what is a slope? Let me explain it to you. Whenever there is a graph and we have this line, slope of a line means this, we drop a perpendicular from here to the x-axis, and okay, you just take 2 points over here. Let us take 2 points over here. So make a vertical line here and a horizontal line like this. Okay, so the slope of this line will be, suppose I say this is A, this point is B, and the perpendiculars meet at P, then slope is equal to BP upon AP, this thing upon this thing. Understood? And see here this, if we take 2 points like this, the slope will be like this. Vertical line this, and this horizontal line. Suppose these are the points A, this is B meeting at P, so again the slope will be BP upon AP. But see, earlier the triangle was on this side, now here the triangle is this side, so this one is known as the negative slope. Here slope is equal to minus of BP upon AP. Okay, this is opposite side now, so this is said to be negative. Or see, how will you understand this? To understand this, you need to know that, see, this graph was starting from here. So okay, so distance is decreasing, right? So actually the slope is the final displacement minus initial displacement upon final time minus the initial time. Okay, so here final displacement is smaller than the big initial one. This will come out to be a negative thing. So okay, slope, you just know it here. I'll give you another small lecture on this so that you'll be understanding it even better. For now, you just know that this type of a line where displacement is increasing, that gives a positive slope, and where the displacement is decreasing, that gives a negative slope. And what was happening in this graph, the body was moving away, displacement was increasing, no? So the body was moving away from the origin. That means a positive slope shows that the body is moving away from the origin, and here the body was coming towards the origin, right? Therefore the displacement was decreasing. So negative slope shows that body is moving towards the origin. You have to remember this always, okay, for any graph. And see here for at any point, how will we get the slope here? What do? We just draw a tangent over here, tangent, okay, like this, and the slope of this tangent will give the speed at a particular point. Slope of tangent at a point gives the velocity at that instant. Okay, because here velocity is changing at every instant, right? And see the slope, this slope here, that this gives us the velocity. Why? Because BP is the vertical distance. This vertical distance was displacement, है ना? And the AP is the horizontal distance. Horizontal distance, what's time? So displacement upon time is velocity. So you have to keep in mind these things, that slope of a displacement time graph always gives us the velocity. Then positive slope shows the body is moving away from origin. Negative slope shows that the body is moving towards the origin. Horizontal line shows that the body is stationary. A line or a graph having a line with increasing slope or a positive slope, this is showing that the body is moving with a uniform velocity and going away from the origin. This type of a graph shows that the body is moving towards the origin but with a uniform velocity. This type of a graph, a curve, will show that the body is moving away from the origin but with a varying speed. Okay, just go through your book, read it just once, and it will be all clear for you all. Velocity time graph and acceleration time graph will be taken in the next lecture.